This is my son Tara. I enlisted his support to help me with this short presentation. My aim is to reflect on a few basic issues in the science of behaviour analysis that many students have difficulty understanding. This is an important issue because if these students then become teachers, their misunderstandings of this science would automatically morph into misinformation about it. Before too long, a culture based on misinformation would then emerge, and this would stifle the spread of any of the known benefits of adopting behaviour analysis for addressing social issues. My concerns may seem overly speculative or even paranoid. In truth, though, the damaging effects have already begun to set in. One recent example has come from students who approached me because they were confused as to why they were being told that behaviour analysis treats people like robots. No sensible person would want to advocate for a science that treats people like this, but this is what they were told about the science I teach. In the wider community, myths about behaviour analysis have taken hold and have impacted negatively on the uptake of effective practices in many areas. In the case of autism, for example, parents in the UK have to resort to using tribunals to bypass obstacles created by misinformation that prevents them accessing gold standard services from professionals trained in applied behaviour analysis. Let's begin this presentation by looking at the implications of adopting different perspectives on the image shown here. This next image simulates the perspective of the scientist who is keen to access physiological information during an observation. This image is taken from Tara's point of view. I tried to simulate his thoughts as he focused on the candle. He suggested the images, and together we played around with their duration. Of course, I can never see his thoughts in the way that he does, and the images shown here are not exactly the same as the thoughts as he experienced them. All of the images so far omit an important element, the passage of time. I have corrected this in the following images by incorporating a film strip shown with 3D perspective. This is a fairly obvious thing to do because the act of observing extends across time, as do candle flames on people. What we perceive as the flame of a candle is not truly fire at all. Rather, it is the luminescence of flowing carbon atoms, which are superheated in the heat of an invisible fire. The image of the flame appears as if it were a thing, but in fact it is a process, a series of chemical changes that are localized above the candle. Living is similarly an active process that extends across time. Strange as it may sound, Tara is the stream of changes that defines his life. The design of investigative techniques must bear this in mind when we aim to study the nature of living things. More on this later. Access to physiological changes would tell more of the story of how Tara changes during the time he is being observed. To say it more formally, this perspective explores details of a biological system during the time it is being observed. I have picked my words very carefully here. Of particular importance is the phrase, during the time he is being observed. This phrase draws attention to the fact that often there are limitations to the time period in which an observation is made. In a clinical setting, this time period is carefully determined. In daily life, we observe each other for various time periods. But the general point I want to make here is that Tara, as with any person, has a history of living prior to a particular observation. And this simple fact raises the question of how far back do we want to go? Well, for a truly complete picture of him, we would need to capture details of all the changes that have taken place since the moment of conception. And that includes details of every cell division of the fertilized egg that was him, the ways in which his genetic inheritance guided the emergence of his body as he developed, his first breath when he was born, and so on and so on. When you take all this into account, we can say the following. When we observe a living entity, we are in fact observing a stream of changes right in front of our eyes. Any recorded changes for a particular period of observation are regarded as evidence of how a biological system with a particular genetic and environmental history continues to change in the current environmental circumstances. No doubt there are those who might say it sounds a bit cold to hear a parent talk like this about his son. Not to me it doesn't, and not to Tara either. Like me, he is fascinated by these facts because they add to his awareness of what defines his existence. I would also argue that supplying anyone with more information about the kinds of changes which make us human is something to be welcomed. As Tara's father, I would go further by saying that if Tara ever needed the skills from anyone trained in the collection of the information obtained from this perspective, I would hope that they are trained to the highest standards. So now we have 3 perspectives in the one observation period. So what do we do with these? Well, we could try to find ways to match the data collected in each. We could, for example, try to identify the physiological correlates of the thoughts as they occurred. To be honest though, this is something only Tara could do because only he has access to his thoughts. Even then, this would be difficult for a variety of reasons. For a start, we do not have the technology that would allow him to monitor the correlates, at least not yet. If we did have the technology, other issues would arise. There are 2 main ones. Firstly, there is the question of how could he focus on observing his thoughts and at the same time focus on the physiological data. If he shifted his focus at any point to either one, then the data would be compromised because there would be interactions between them. The result would be different from the independent streams of change shown in the image. From yet another perspective, though, this is not necessarily a problem. Perhaps it would help Tara to be able to have some feedback on his thoughts from the physiological perspective, as in biofeedback, for example. Theoretically, at least, this is an issue that would be interesting for him to investigate. The other main issue is this question. Would it be correct to conclude that the physiological data explained Tara's thoughts? From what we have seen so far, this would not be the correct conclusion. The physiological data are simply data about the kinds of changes that are occurring, not an explanation for why these data occur. In the search for explanations, we generally collect data and then devise strategies to help determine the variables responsible for the occurrence of these data. The physiological data only give us more information about the kinds of changes that are happening. Their occurrence doesn't explain why they occurred. Another issue concerns the measurement of Tara's thoughts. When you hear mention of measurement, I suppose the first question that comes to mind is, why on earth would you want to do this? And how would you do it? That's another question. Let's take this second question first. Traditionally, psychologists rely on verbal reports as a way of measuring someone's thoughts. But this is a bit of a cheat, really. A verbal report is a verbal report. It is not a thought. How a thought gets connected to a verbal report is a completely different issue, one that behaviour analysts have discussed at length. But that is for another lesson. For now, we need only concern ourselves with flagging up the issue so you do not take it for granted that verbal reports measure thoughts. Again, though, there is a follow-up question related to the search for explanations of an observation. Does a verbal report explain anything? From the images shown here, it doesn't make sense to suggest it does. As with the argument regarding physiology, a verbal report is data, and as such it cannot explain itself, or indeed it cannot explain the thought it supposedly measures. Tied in with this fact is another issue regarding measurement. Normally, when you learn about science, you are taught that an essential consideration is the development of an objective perspective. Essentially, this ties scientists down to what can be observed amongst a group of people. Given that a group of people would not be able to see towers in our world, this point is usually picked up incorrectly as implying that because we cannot observe from Tara's perspective, we must rule his inner world out of consideration for analysis. Perhaps this is the origin of the suggestion that behaviour analysis regards people as robots with nothing worthwhile happening inside them. Skinner was a radical behaviourist precisely because he rejected this conclusion. Tara does not rule out of contention for analysis the changes he observes in himself when he meditates on the candle. The suggestion that others cannot see Tara's inner world is a fact, not a theory, and the traditional emphasis of adopting an objective perspective pays homage to this point. However, what marks Skinner's perspective as being distinctive from a traditional perspective is his concern with the practice of science itself. Science is what people do. Scientists extend across time just like any other person. That means we must be careful to include limitations of an objective perspective into the practice of science itself. The usual response to this point is that shared public observations make it easy to agree on the definition of what is being observed. True, but rather than this being used as a justification for denying the value of a private perspective, it too could be used in conjunction with a private perspective, just as we discussed earlier when talking about physiology. This seems reasonable, but the usual response is that because there is no public agreement on what is being observed, one is not doing science. Technically, this is correct if by doing science you mean working with observations that are publicly agreed. As a behaviour analyst myself, I know that when I close my eyes or when I watch a candle, I see things others cannot see. I don't suddenly stop being a scientist. No, I take the next step that any behaviour analyst would do when searching for an explanation of what is observed. To understand this next step, let's remove the two perspectives we have been discussing in depth and return to the first image. The basic scientific method looks like this. An initial observation is made over a period of time during which baseline data are collected. Then, a change is made in some aspect of the context, and we monitor the effects on the initial baseline data. The goal is to extract some conclusion or other about the relation between the change in context and the corresponding changes in the data that were subsequently observed. Whatever changes are produced in the baseline data, they are produced only when there is a change in the context. This means the new data are explained by the change in context. This nugget of truth has profound implications for doing science. It is so obviously true that you might even feel a mild reaction against it. Surely it can't be as simple as that. Perhaps the most important lesson from using the scientific method is that it is no longer necessary to engage in endless speculation about the causes of particular kinds of changes. If we can make them happen, then the things we do to make them happen provide us with the explanation for their occurrence. It is as if the answer is hidden in plain sight. This conclusion also doesn't ignore all the parallel perspectives we discussed earlier. They still exist, But now we can incorporate the lessons from this scientific method. We can say that the change in the context was responsible for the changes in the physiology that are observed. Similarly, the change in context is responsible for the changes that Tara observed. Third, we can say that Tara is now a changed person. We will move on now to examine some issues in data collection. Not of thoughts or physiology as usually conceived, but data that comes from consideration of the relation between aspects of an organism and the environment through which it passes. Generally, these data are called behaviour. As used by behaviour analysts, though, this term has a very different meaning from the way it is used in everyday language. In everyday language, there is behaviour and there is cognition. By the way, this is also the view of much of general psychology. Used this way, behaviour is viewed as something superficial compared to cognition. When behaviour analysts use the term behaviour, it is no wonder that the science is judged to provide only a superficial understanding of what it means to be a person. Those who already have a shallow definition of behaviour assume that it is appropriate to judge behaviour analysis with their own shallow definition. In behaviour analysis, however, the term behaviour refers to the combined perspectives of all of the kinds of changes we have been discussing so far. This is a holistic perspective. A person is their behaviour, is all of the changes that flow across time and space. To help me address this issue further, I have produced this image of Tara in a landscape bereft of experiences. We don't exist like this, so let's examine him in a context that is familiar to him. Here we see him in his hometown. The challenge graphically for me is to represent the complexity of what happens as he interacts with a physical and social environment. Every part of his physical body stands in relation to something in the environment. What I have done is simply to sample a few relations by marking them with lines as he walks through the town. In this image, I have tried another way to capture the complexity of flowing through time and space. As he walks, he is the focal point of a huge range of influences. Skinner phrased it this way when he discussed the challenges facing the analysis of change. He said that a person is the focal point of a number of influences. In this image, Tara is now in a landscape of other potential experiences, and I have selected one to show one way of mapping changes across time. This time we focus on other people. Ideally, I should really use film strips as used earlier and map them onto each person as they change in the video clip, but I simply do not have the graphical skills to do this. Nevertheless, the lines drawn for each of these people do track aspects of their changes. This will become an important point later when we delve into natural laws of behaviour change. In this image, I bring you back to a slightly different version of the original way I represented the behavioural stream. By running the film strip through Tara in this way, it is clear that there is nothing remotely superficial about taking a snapshot of him in time. As I said earlier, Tara is a stream of changes, as am I, and I would have no problem replacing him with a picture of me in the image. I think it would be difficult to argue that I see myself as a robot, or that I see myself as a black box with no consciousness, or whatever nonsense you've come across about how behaviour analysis views people. Moving on from Tara, this image represents any individual whose behaviour is to be monitored across time. The shaded area represents the time period selected for observation. The behavior could be, for example, reading, writing, eating, or walking. Any behavior, really. Common to all these behaviors is the fact that often they occur in many different forms, and yet they're still called the same thing. For example, there are many different ways in which a person could read, write, eat, or walk. Someone could eat with their hands, or use a spoon, or use a fork, or chopsticks, or whatever. The behavior would always be eating. Skinner recognized that when a behavior has numerous topographies, it represents a challenge for determining how to investigate it. He solved this problem when he recognized that we are dealing with a class of behaviors that share a common outcome or function. He called behaviors that have different forms but the same outcome operant behavior. Being a natural science, behavior analysis uses experimental techniques that are familiar to all natural sciences. In other words, operant behavior is studied using the scientific method, whereby baseline measurements are taken initially, and then some aspect of its interaction with the environment is altered. When Skinner first studied the consequences of an operant, he found that the likelihood of it occurring again became predictable, so much so that natural laws of behavior were revealed. Principles of reinforcement and punishment were subsequently formulated when it was possible to identify circumstances that either increased the likelihood of behavior or decreased the likelihood of behavior. This was not a theory of behavior, but a statement of fact. To conclude, when we observe a person, we need to bear in mind that we are observing a process of change. How we actually study this process can get very complicated, but there should be no excuses for misrepresenting a science if you do not take the time to learn about it. Regarding the suggestion that the science of behavior analysis treats people like robots, my advice to students and parents of children with autism is to ask those who make such statements about how they arrived at this conclusion. Are they talking about the science discussed here, or are they talking about their understanding of the science they haven't studied? It should be an interesting discussion.